The morning of October 15th, 1943, Grumman Aircraft Engineering Corporation's plant in Bethpage, Long Island. The assembly line stretched nearly a quarter-mile through the cavernous factory floor where the distinctive silhouette of the F6F Hellcat took shape beneath banks of overhead lighting. Production supervisor William Schwendler walked the line with his clipboard, watching workers rivet aluminum panels onto airframes that would soon carry American pilots into combat above the Pacific. What Schwendler witnessed that morning would have seemed impossible 18 months earlier. Every 8 minutes, another completed Hellcat rolled toward the flight test area. The mathematics were staggering. In the time it took to drink a cup of coffee, American industry delivered another fighter aircraft capable of engaging the best pilots Imperial Japan could field. By December of that year, this single facility would achieve something unprecedented in aviation history, producing over 12,000 combat aircraft in 24 months. If you're enjoying this deep dive into the story, hit the subscribe button and let us know in the comments from where in the world you are watching from today. But the real story begins earlier, in the desperate months following Pearl Harbor, when American naval aviation faced a crisis that threatened to hand the Pacific to Japanese forces. The F4F Wildcat, America's primary carrier fighter, was being systematically outclassed by the Mitsubishi A6M0. In aerial combat, Japanese pilots were achieving kill ratios that made American victory seem mathematically impossible. The Zero could outclimb, outturn, and outrange any fighter the United States Navy possessed. At Coral Sea and Midway, American pilots survived through tactics and determination, but everyone understood these were temporary advantages. Japanese aircraft production, combined with pilot experience gained in China, created a qualitative superiority that numbers alone could not overcome. Roy Grumman understood this reality when he gathered his engineering team in January 1942. The Navy had approached Grumman with specifications for a new carrier fighter, but the requirements seemed contradictory. The aircraft needed to match Zero performance while maintaining the structural strength necessary for carrier operations. It needed range sufficient for Pacific distances, while carrying armament heavy enough to destroy enemy aircraft with brief bursts. Most critically, it needed to be designed for mass production. The Navy's analysis was brutally clear. Japanese pilot training produced approximately 1,000 new aviators annually. American training facilities could potentially produce 10 times that number, but only if sufficient aircraft were available. Quality would need to emerge from quantity. The F6F Hellcat represented Grumman's response to this challenge. The design philosophy differed fundamentally from previous fighter development. Instead of pursuing absolute performance, engineers optimized for manufacturing efficiency while maintaining competitive capability. The aircraft used conventional construction methods that could be executed by workers with minimal specialized training. The fuselage was built in sections that could be manufactured simultaneously rather than sequentially. Wings used standardized ribs and spars that required no hand fitting. The engine installation was designed so power plants could be mounted and removed quickly during production and maintenance. Every system was engineered for simplicity and reliability rather than theoretical perfection. But designing for mass production meant nothing without manufacturing capacity. In early 1942, Grumman occupied a relatively small facility in Bethpage with limited production capability. The company had built fewer than 3,000 aircraft since its founding in 1929. The Navy's requirements called for production rates that would dwarf anything Grumman had previously achieved. The solution required transforming not just Grumman's facilities, but the entire approach to aircraft manufacturing. In March 1942, the War Production Board allocated materials and labor for massive expansion of the Bethpage plant. Construction began on additional assembly buildings, while production of early Hellcats continued in existing facilities. The construction project consumed 6 months and $30 million. When completed, the expanded facility covered over 2 million square feet of production space. The main assembly line stretched 1,200 feet through multiple buildings connected by overhead conveyor systems. Raw materials entered at one end, completed aircraft emerged at the other. The first production F6F Hellcat completed its maiden flight on October 3, 1942. Initial production was measured in dozens per month, while workers learned procedures and engineers refined processes. By January 1943, monthly production reached 100 aircraft. By March, it had doubled to 200. The acceleration continued through spring and summer of 1943. Each month brought new production records as the manufacturing system matured. Workers developed expertise, supervisors optimized workflows, and engineers eliminated bottlenecks. The learning curve was steep, but consistent improvement demonstrated that mass production of complex aircraft was achievable. The breakthrough came in September 1943, when monthly production exceeded 400 aircraft. This represented a production rate of more than 13 Hellcats daily, far exceeding any previous American fighter production. But even these numbers would prove inadequate for the Navy's expanding requirements. Operation Galvanic, the assault on the Gilbert Islands, was scheduled for November 1943. Operation Flintlock would follow in the Marshalls in early 1944. Each operation required more carrier aircraft to support amphibious assaults against increasingly sophisticated Japanese defenses. The Navy needed Hellcats faster than even the improved production rates could deliver. The response was characteristic of American industrial mobilization. Rather than accepting production constraints, Grumman implemented additional shifts and expanded the workforce. By October 1943, the Bethpage plant operated 24 hours daily with 3 complete shifts. Employment exceeded 15,000 workers, many of them women entering industrial work for the first time. The demographic transformation was as significant as the industrial expansion. Traditional aircraft manufacturing had relied on skilled male workers with years of specialized training. Wartime production demanded different approaches. Training programs were compressed from months to weeks. Complex procedures were broken into simple steps that could be mastered quickly. Women comprised nearly 40% of the workforce by late 1943. Many had no previous industrial experience, but demonstrated remarkable adaptability to precision manufacturing. Rose Monroe, who worked on Hellcat final assembly, became the inspiration for Rosie the Riveter after being featured in a wartime documentary filmed at the plant. The cultural shift extended beyond demographics. Traditional aircraft manufacturing emphasized craftsmanship and individual skill. Mass production required standardization and systematic approaches. Workers learned to follow precise procedures rather than relying on personal judgment. Quality control became a separate function, rather than each worker's individual responsibility. This transformation was not without resistance. Experienced workers worried that production emphasis would compromise quality. Engineers questioned whether complex aircraft could be built using simplified methods. Management faced constant pressure to balance speed against reliability. The answer came from operational results in the Pacific. As Hellcats reached combat units in increasing numbers, pilot reports provided validation for the production approach. The aircraft proved remarkably reliable, despite rapid manufacturing. More importantly, its performance characteristics were proving superior to Japanese fighters in actual combat. The first major engagement occurred during Operation Galvanic in November 1943. Hellcats from Essex-class carriers provided air cover for the assault on Betio and Makin Islands. Japanese opposition was fierce, but American pilots achieved favorable kill ratios for the first time since Pearl Harbor. Lieutenant Commander Edward Butch O'Hare, flying a Hellcat from USS Enterprise, described the aircraft's capabilities in a combat report filed after the Gilbert Islands operation. The F6F maintains energy in vertical maneuvers where the zero loses effectiveness. We can dictate engagement terms, attacking when advantageous, and disengaging when necessary. The aircraft's structural strength allows aggressive maneuvering that would destroy lighter fighters. These reports reached Grumman just as the company was implementing its most ambitious production expansion. The success of Hellcats in combat validated the design philosophy and justified maximum production effort. In December 1943, Grumman committed to achieving production rates that would have seemed impossible just months earlier. The target was established at 600 aircraft monthly by March 1944. This would require producing 20 Hellcats daily, 1 aircraft every 36 minutes during production hours. The goal seemed absurd, but recent success had created confidence that American industrial capacity could achieve seemingly impossible objectives. The effort began with systematic analysis of CUMSI's every production process. Industrial engineers with stopwatches studied each operation, identifying inefficiencies and developing improvements. The wing assembly process was redesigned to eliminate transportation between workstations. Engine installation procedures were modified to reduce handling time. Final assembly operations were completely reorganized using principles adapted from automotive production. Instead of building each aircraft individually, assembly lines processed multiple airframes simultaneously. Components were delivered to workstations using precise scheduling that eliminated waiting time. The most significant innovation was implementation of parallel production streams. Rather than building each Hellcat sequentially through all operations, multiple assembly lines operated simultaneously. Wings were manufactured in one building, while fuselages were built in another. Final assembly brought these major components together. By February 1944, daily production exceeded 15 aircraft. March brought the achievement of 20 daily completions. April saw production reach 22 aircraft daily, exceeding even the ambitious targets. May brought a new milestone when daily production reached 25 Hellcats. The mathematics of this achievement were staggering. Every working day, Grumman delivered to the Navy 25 fighter aircraft capable of engaging enemy forces on equal terms. In the time required for a single Zero to be completed at Mitsubishi factories, American industry produced nearly a week's worth of Hellcats. But production numbers told only part of the story. Each Hellcat represented not just an aircraft, but a complete weapons system. The standard armament included 6 50-caliber machine guns with 400 rounds per gun. Each aircraft carried sufficient ammunition for approximately 20 seconds of continuous fire. The 50-caliber ammunition was itself a marvel of mass production. Lake City Army ammunition plant in Missouri produced millions of rounds monthly using automated machinery that operated continuously. The ammunition was designed for maximum effectiveness against aircraft, featuring armor-piercing incendiary rounds that could penetrate Japanese aircraft structure and ignite fuel systems. Beyond weapons, each Hellcat incorporated sophisticated systems that multiplied its effectiveness. The R2800 double wasp engine produced over 2,000 horsepower, providing performance that exceeded Japanese fighter capabilities. The engine was manufactured by Pratt & Whitney using mass production techniques that delivered reliability unmatched by Axis power plants. The propeller was manufactured by Curtiss-Wright using constant speed technology that optimized performance across all flight conditions. The hydraulic system operated landing gear, flaps, and cowl flaps with precision that simplified pilot workload. The electrical system powered radios, navigation equipment, and lighting that enabled operations in conditions where Japanese aircraft were ineffective. Each of these components represented separate industrial achievements. The R2800 engine required precision manufacturing of thousands of parts with tolerances measured in thousandths of inches. Monthly production exceeded 1,000 engines, each requiring approximately 200 hours of machining and assembly. The propellers demanded metallurgical expertise in aluminum alloys and precision balancing that ensured smooth operation under extreme stress. Radio equipment incorporated vacuum tubes and precision components, manufactured to specifications that exceeded commercial standards. But the real achievement was integration of all these systems into aircraft that could be manufactured rapidly while maintaining performance and reliability. This required design philosophy that prioritized production efficiency over theoretical optimization. If you find this story engaging, please take a moment to subscribe and enable notifications. It helps us continue producing in-depth content like this. The Japanese response to increasing Hellcat production revealed the fundamental challenge facing their military aviation. Imperial Navy pilots were among the world's most experienced, having gained combat experience in China since 1937. Their aircraft, particularly the Zero, had proven superior to everything they encountered until 1943. But Japanese aircraft production was constrained by industrial limitations that could not be overcome through improved design or pilot skill. Mitsubishi manufactured approximately 3,000 Zero fighters during 1943. This production rate, while impressive by Japanese standards, was completely inadequate against American production rates, approaching 10,000 fighters annually from Grumman alone. The disparity extended beyond simple numbers. Japanese production relied on skilled craftsmen who assembled each aircraft individually. Quality was excellent, but production rates were limited by human capacity. American production used industrial techniques that multiplied human productivity through machinery and systematic processes. Captain Saburo Sakai, one of Japan's most successful fighter pilots, encountered Hellcats for the first time during the Marshall Islands campaign in January 1944. His post-war memoir described the shock of facing overwhelming numbers of capable American aircraft. We had become accustomed to numerical disadvantage, but now faced aircraft that matched our performance while outnumbering us impossibly. For every Zero we could field, Americans seemed to have 5 or 6 Hellcats. This numerical disparity was exactly what American planners had intended. The strategy was not to build aircraft superior to Japanese fighters, but to build aircraft capable of engaging Japanese fighters successfully while maintaining production rates that would create insurmountable numerical advantages. The results became apparent during Operation Hailstone in February 1944. Task Force 58, including 9 Essex-class carriers loaded with Hellcats, attacked the Japanese naval base at Truk. The 2-day operation destroyed over 200 Japanese aircraft while losing fewer than 30 American planes. The kill ratios achieved during Hailstone demonstrated that American pilots flying Hellcats could engage veteran Japanese pilots on favorable terms. But more importantly, the operation showed that American production rates could sustain such losses indefinitely, while Japanese forces could not replace their aircraft or pilots. March 1944 brought the achievement that would define the Hellcats' impact on Pacific warfare. In that single month, Grumman delivered 742 F6F Hellcats to the Navy. This represented more fighters than the entire Japanese Navy possessed at the beginning of the war. The production rate continued accelerating through spring 1944. April saw 800 completions, May brought 867. June achieved the milestone of 900 Hellcats delivered in 30 days. This meant that every 3.5 hours, another Hellcat rolled off the production line. The strategic implications were profound. Japanese military planners had based their Pacific strategy on the assumption that American industrial capacity, while large, could not be mobilized quickly enough to affect the war's outcome. They believed that by achieving decisive victories in 1942, they could force American negotiation before industrial production reached full capacity. The Hellcat production rates demonstrated the fallacy of this assumption. American industry had not only mobilized rapidly, but achieved production rates that exceeded Japan's most pessimistic estimates. The mathematical reality made Japanese victory impossible, regardless of pilot skill or tactical innovation. But the achievement extended beyond manufacturing. Each Hellcat required a pilot, and American training programs were producing aviators at rates that matched aircraft production. The Navy had expanded flight training from a few hundred pilots annually to several thousand. Training facilities were constructed across the United States using standardized curricula that compressed training time while maintaining effectiveness. The typical American pilot received approximately 200 hours of flight training before assignment to combat units. This included gunnery training, using live ammunition against target drones, formation flying in large groups, and instrument training for all-weather operations. Japanese pilot training, constrained by fuel shortages and limited aircraft, provided far fewer flight hours. More critically, American training included extensive practice in combat tactics specifically developed for Hellcat capabilities. Pilots learned to exploit the aircraft's strengths, superior diving speed, heavy armament, and structural strength, while avoiding situations where Zero advantages might prove decisive. The Thutch weave became standard doctrine for Hellcat operations. This tactic, developed by Commander John Thutch based on early combat experience, used pairs of fighters in coordinated maneuvers that provided mutual support while maximizing the Hellcat's performance advantages. The weave allowed American pilots to engage multiple Japanese fighters simultaneously while reducing vulnerability to the Zero's superior maneuverability. By summer 1944, the combination of overwhelming production and effective tactics had transformed Pacific air warfare. American carrier task forces operated with impunity, knowing that Japanese air attacks could be defeated through sheer numerical superiority, even if individual engagements proved costly. The Battle of the Philippine Sea, in June 1944, demonstrated this transformation. Japanese forces launched their largest carrier aviation attack since Pearl Harbor, committing over 400 aircraft against Task Force 58. American defenders, flying primarily Hellcats, destroyed approximately 350 Japanese aircraft while losing fewer than 30 of their own. The engagement became known as the Great Marianas Turkey Shoot because American pilots described shooting down Japanese aircraft as easily as hunting turkeys. The kill ratios were not achieved through superior individual pilot skill, but through numerical advantages that allowed American pilots to engage under favorable conditions while avoiding unfavorable situations. But perhaps the most significant achievement was sustainability. After the Philippine Sea battle, American carriers were restocked with replacement aircraft and pilots within days. Japanese forces never recovered from their losses. The industrial capacity that produced Hellcats at unprecedented rates also supported training programs that replaced lost pilots faster than combat could eliminate them. The final 6 months of 1944 saw Hellcat production reach levels that seemed to defy physical limitations. September brought 1,000 completed aircraft. October saw 1,050. November achieved 1,100 deliveries, representing more than 36 Hellcats daily. By December 1944, exactly 2 years after the first production aircraft completed its maiden flight, Grumman had delivered over 8,000 F6F Hellcats to the Navy. This production rate represented one of the most remarkable industrial achievements in human history, a complex, high-performance aircraft manufactured at rates exceeding 1,000 monthly. The achievement was not limited to Grumman. General Motors' Eastern Aircraft Division, operating facilities in New Jersey, added additional production capacity in late 1944. By war's end, combined production from both facilities exceeded 12,000 Hellcats, making it the most numerous American fighter aircraft of World War II. The realization struck Lieutenant Commander Hiroyoshi Nishizawa on the morning of October 20, 1944, as he watched American carrier aircraft approach Leyte Gulf in formations that seemed to stretch beyond the horizon. Nishizawa, Japan's leading fighter ace with over 100 confirmed victories, understood immediately that the war had entered a phase where individual skill became irrelevant against overwhelming numbers. Standing beside his Zero on the flight line at Clark Field in the Philippines, Nishizawa counted more than 60 American fighters in the first wave alone. His own squadron could muster 8 operational aircraft. The mathematics were brutal and undeniable. For every Japanese fighter that could engage, the Americans possessed nearly 8 Hellcats. But the numbers told only part of the story that would unfold over the following days. These were not the desperate, hastily trained American pilots that Japanese forces had encountered in 1942. These were products of an industrial training system that had transformed aviation education from individual instruction to mass production of competent pilots. The American pilots approaching Leyte had trained on aircraft identical to those they flew in combat. They had practiced gunnery using live ammunition until shooting became instinctive. They had flown formation maneuvers in groups of hundreds, learning coordination that Japanese pilots could no longer practice due to fuel shortages and aircraft limitations. Lieutenant Alex Vraciu, flying with Fighting Squadron 16 from USS Lexington, represented this new generation of American naval aviators. Unlike the experienced pilots who had fought at Coral Sea and Midway, Vraciu had learned to fly in Hellcats from his first training. Flight. The aircraft's characteristics were as familiar to him as walking. During the October 20th strike on Clark Field, Vraciu's division of 4 Hellcats engaged 12 Japanese fighters attempting to intercept the American formation. The engagement lasted fewer than 3 minutes. When it ended, 8 Japanese aircraft had been destroyed with no American losses. Vraciu personally claimed 4 victories, bringing his total to 19 confirmed kills. The engagement demonstrated how overwhelming production had created qualitative advantages beyond simple numbers. Each American pilot flew an aircraft that had been manufactured using standardized procedures ensuring consistent performance. Their weapons had been test-fired before installation. Their ammunition was produced using quality control procedures that guaranteed reliability. Japanese pilots faced increasing uncertainty about their equipment. Zero production had declined dramatically as American bombing destroyed factories and disrupted supply chains. The aircraft that reached combat units were often assembled from whatever parts remained available. Quality control had collapsed under pressure to deliver any operational aircraft regardless of condition. Captain Minoru Genda, the brilliant tactician who had planned the Pearl Harbor attack, assessed the situation in his October 1944 intelligence report. Enemy aircraft production has created numerical superiority so overwhelming that tactical innovation cannot compensate. Our pilots engage ratios of 10 to 1 or worse. Even perfect execution of attacks results in losses we cannot sustain. The production achievement that had created this situation represented perhaps the most remarkable transformation in industrial history. In 36 months, American aircraft manufacturing had evolved from producing hundreds of fighters annually to delivering over 1,000 monthly from single facilities. The Hellcat production line at Bethpage operated with precision that would have impressed Henry Ford. Raw aluminum entered the facility on railroad cars and emerged as completed fighter aircraft 48 hours later. Every operation was timed, every movement was planned, every procedure was optimized for maximum efficiency. Workers arrived each morning to find their workstations prepared with tools, parts, and materials arranged according to precisely calculated requirements. Visual aids indicated proper procedures for each operation. Quality checkpoints ensured standards were maintained despite production pressure. The achievement extended far beyond manufacturing. Supporting the Hellcat required an entire industrial ecosystem. Aluminum production had expanded to provide thousands of tons monthly. Engine manufacturers delivered power plants at rates matching aircraft production. Propeller companies, instrument makers, and electronics manufacturers all scaled their operations to support unprecedented aircraft deliveries. This industrial coordination was planned and executed with the same systematic approach used for aircraft assembly. Raw materials were allocated according to priority schedules. Transportation systems moved components according to precise timing. Inventory levels were calculated to support production without waste. By late 1944, the American industrial system was producing complete weapons systems, aircraft, engines, propellers, instruments, radios, and ammunition at rates that exceeded most pre-war estimates for total production. The Hellcat represented the culmination of this achievement, but the most profound impact was psychological. Japanese pilots who had dominated Pacific skies since 1937 found themselves facing opponents who matched their skills while possessing overwhelming material advantages. The experience was demoralizing beyond anything previous combat had prepared them for. Warrant Officer Saburo Sakai described his final combat engagement in his post-war memoir. Above Iwo Jima, in February 1945, our formation of 6 Zeros was attacked by more than 30 Hellcats. We had trained for years to expect numerical disadvantage, but this exceeded our most pessimistic assumptions. Fighting became pointless. Survival became the only objective. The engagement Sakai described occurred during Operation Detachment, the assault on Iwo Jima. American carrier task forces approached the island with over 800 Hellcats embarked, more fighters than the entire Japanese Navy possessed. The numerical advantage was so overwhelming that American commanders authorized liberal use of ammunition for reconnaissance by fire and area suppression. Japanese defensive preparations on Iwo Jima had anticipated air attacks, but the scale of American operations exceeded all planning assumptions. On February 19th, the invasion's first day, American aircraft flew over 3,000 sorties against the island. Japanese defenders counted continuous waves of attackers from dawn until darkness. The sustained tempo was possible only because American production had created aircraft availability that treated individual airplanes as expendable items. Lost aircraft were immediately replaced from carrier reserves. Damaged aircraft were rapidly repaired using standardized parts and procedures. The operational tempo never slackened due to equipment limitations. Japanese forces attempted to respond with kamikaze attacks, recognizing that conventional air combat had become impossible. But even suicide tactics required aircraft, and Japanese production could not provide sufficient numbers to affect American operations significantly. The final Japanese carrier aviation attack occurred during Operation Tengo in April 1945. The attack force totaled fewer than 100 aircraft, launched from bases in Japan against American naval forces off Okinawa. American defenders included over 400 Hellcats from multiple carrier task groups. The engagement lasted 3 hours and resulted in the virtual elimination of remaining Japanese carrier aviation. Fewer than 20 Japanese aircraft survived to return to their bases. American losses totaled 6 aircraft, achieving kill ratios that exceeded 20-1 in favor of the defenders. Lieutenant Eugene Valencia, flying with Fighting Squadron 9 from USS Yorktown, achieved 4 confirmed kills during the engagement, bringing his total to 23 victories. His combat report noted, "Enemy aircraft appeared to be flown by inexperienced pilots using obsolete tactics. Our numerical advantage allowed engagement under ideal conditions with multiple opportunities to achieve favorable positions." Valencia's observation reflected the cumulative effect of unsustainable Japanese losses. The experienced pilots who had dominated early Pacific combat were dead, missing, or grounded by fuel shortages. Replacement pilots received minimal training due to aircraft and fuel limitations. By 1945, Japanese pilot quality had declined precipitously, while American pilot training had reached unprecedented levels of effectiveness. The training differential reflected the same industrial advantages that created Hellcat production superiority. American flight training consumed vast quantities of aviation gasoline, which domestic production provided without limitation. Japanese training was constrained by fuel shortages that limited flight time to absolute minimums. American pilots practiced gunnery using live ammunition until shooting became automatic. Japanese pilots often reached combat units, having fired fewer than 50 practice rounds. American pilots trained in large formations that replicated combat conditions. Japanese pilots practiced individually or in small groups that bore no resemblance to actual operations. The industrial system that produced Hellcats also supported training operations at unprecedented scale. Multiple training bases operated continuously, graduating hundreds of pilots monthly. Standardized curricula ensured consistent instruction regardless of location. Training aircraft were available in quantities that permitted extensive practice without concern for conservation. By war's end in August 1945, American naval aviation training programs had graduated over 60,000 pilots. Japanese programs had produced fewer than 10,000 during the same period, and most of these had been killed or incapacitated by combat losses that could not be replaced. The final tally of Hellcat production reached 12,275 aircraft, delivered between June 1942 and November 1945. Peak monthly production exceeded 1,000 aircraft, making the Hellcat the most rapidly produced fighter in aviation history. Combat records credited Hellcat pilots with destroying 5,156 enemy aircraft, while losing approximately 270 Hellcats in air-to-air combat. This achievement represented kill ratios exceeding 19-1, the most favorable combat record of any fighter aircraft in World War II. But statistics could not capture the strategic impact of overwhelming Hellcat production. By creating numerical superiority so extreme that tactical skill became irrelevant, American industry had solved the fundamental problem that had threatened Pacific victory in 1942. The Zero's superior performance characteristics remained unchanged throughout the war. Japanese pilot training methods continued to emphasize individual skill and aggressive tactics that had proven successful in China. But these advantages became meaningless when facing opponents who possessed such overwhelming numerical superiority that engagement terms could be dictated entirely by American forces. The transformation was visible in pilot accounts from successive campaigns. Early Pacific battles featured individual dogfights where aircraft and pilot quality determined outcomes. By 1944, combat resembled coordinated attacks by overwhelming numbers against isolated defenders who had no possibility of effective resistance. Japanese military leadership recognized this transformation, but could not respond effectively within existing industrial constraints. Increasing aircraft production required resources that were already committed to other essential programs. Training more pilots required fuel and aircraft that were not available. The industrial foundation necessary to compete with American production simply did not exist. The lesson extended beyond military aviation to fundamental questions about industrial warfare. In conflicts where material production determined outcomes, industrial capacity became more important than traditional military virtues like courage, skill, and tactical innovation. The Japanese pilots who engaged Hellcats during the final 2 years of Pacific combat were often extraordinarily brave and sometimes tactically brilliant. But courage and brilliance could not overcome mathematical realities created by industrial production rates that exceeded Japanese capabilities by orders of magnitude. Lieutenant Commander Nishizawa, the ace who had watched American formations approach Leyte Gulf in October 1944, was killed in combat over the Philippines 2 weeks later. His death symbolized the fate of Japanese naval aviation, individual excellence, overwhelmed by systemic advantages that could not be matched or countered. The Hellcat represented the ultimate expression of American industrial mobilization. From initial design to peak production required fewer than 3 years, demonstrating that democratic societies could mobilize resources and coordinate efforts as effectively as totalitarian regimes while maintaining industrial efficiency that exceeded authoritarian capabilities. The aircraft itself was competent rather than exceptional. Its performance was adequate rather than superior. But adequacy multiplied by overwhelming numbers created dominance that exceptional performance in limited quantities could not match. The mathematics were written across Pacific battlefields in terms that permitted no misinterpretation. 12,000 Hellcats produced in 3 years versus 3,000 Zeros produced in 6 years. 60,000 American pilots trained versus 10,000 Japanese pilots trained. 5,000 enemy aircraft destroyed versus 270 Hellcats lost in air combat. These numbers represented not just production statistics, but the translation of industrial capacity into military power that proved decisive in determining Pacific War outcomes. The Hellcat was the physical manifestation of American industrial supremacy, proof that in modern warfare, production capacity could create advantages that skill and determination alone could not overcome. The war ended in August 1945, with American carrier task forces positioned off the Japanese coast, their decks loaded with Hellcats that represented the continuation of production lines still operating at peak capacity. Japanese resistance had collapsed not because Japanese soldiers lacked courage, but because the industrial foundation supporting their military had been overwhelmed by production capabilities that exceeded all previous historical precedents. Thank you for watching. For more detailed historical breakdowns, check out the other videos on your screen now and don't forget to subscribe.